Okay, in number 1, we are told that a particle is starting from rest at the point 2, 0, and it is moving along the x-axis with a constant positive acceleration. Which of the following could be the graph of the distance s at t of the particle from the origin for a function of time t? So if we're starting at the origin, and we've moved over to the particle is moved or at 2, 0. Well, this is a distance s at t versus time. So notice this is distance versus time. If we go through and look at our distance, then our distance formula, that would be 2 minus 0 all squared plus 0 minus 0 all squared. That's one way to look at it. And so the distance is going to be the square root of 2 squared. So that distance is 2. So whenever we're moving along, the particle starts from rest and we're at the point 2, 0. Well, as far as time would be 0 at rest. So we're really looking at time being 0 and our distance being 2. So that's why we would end up here. And again, looking at this, thinking about it, our acceleration is a constant positive. This is again talking about distance. So we're going to go all the way back up, and we need something that's more of a parabolic shape. So the correct answer for this one would be A. Number 2, we've got a bug crawling on a vertical wire. We have the velocity versus time graph here. And I want to know for what value t does the bug change directions. Well, we know when v at t is 0, then we know the particle has stopped. And if our velocity is positive, the particle is moving right. If velocity is negative, then our particle is moving left. And so notice here, if we're above the x-axis, or in this case time t-axis, then I have positive velocity, below is negative velocity, and here we've stopped, so I think it would have to be answer choice C. For D, we want to know the total distance traveled for part 3. So if we want to know total distance, then we would integrate our speed, the absolute value of v at t. And so to make a speed graph from this, then what we can do, since it's the absolute value of velocity, is we can just flip our graph over. We can look at this to be the graph of speed. And so for that total distance, it's going to be this bounded area here. And if you go through your formulas, you should end up with answer choice B. Okay, for our next problem, you need to know average velocity. Average velocity is going to be the average rate of change of your position. So for this problem, notice this is a calculator problem. You would need to find 1 over b minus a, or 1 over the time difference, or 3 minus 0. You would integrate from 0 to 3 of your velocity function. And this again is a calculator problem, so you would just type this into your calculator and hopefully you would get answer choice A. For number 5, again, you've got a calculator problem. You've got a position. You want to know in the first 4 seconds how many times does the velocity of the object equal 0. So since we have a position function, we do need to look at y prime. And so y prime at t, we could do this by hand. That's going to be 5/6, or negative 5/6 sine of 5t. And then we're going to have minus 5/4 cosine of 5t, or you could just type that straight in your calculator. But you would need to graph this, and then you're just going to count how many times it crosses the x-axis, and it should cross the x-axis a total of 6 times during the first 4 seconds. Okay, our next question is not a calculator problem, and here we have a particle moves along the x-axis time greater than 0. Its position is given by this, and we want to know at what time t is the particle at rest. Again, we know particle is at rest when the velocity is 0. And to get to velocity, we would have to take the derivative of the position. So x prime at t is going to be 6t squared minus 42t plus 72. And now we would need to set this equal to 0. We can get rid of a common factor of 6. So we have t squared minus 7t plus 12. We would factor this, and we do need to pay attention that t was greater than 0, but I believe once we solve this quadratic, both time values should be greater than 0. So here we have time at 4 and time at 3. So that's going to give us answer choice E. Right, number 6. Again, no calculator, and we have a particle moving along the x-axis. We have a position, and then at what time t is the velocity of the particle? 0. And so we're going to go through a very similar process here. Since we have position, we're going to take the derivative to get to velocity. And so that's going to be 2 times t minus 6. We're going to set that equal to 0 and solve. And so at time t equals 3 is going to be the first time that this velocity is 0. Okay, number 8, this is a calculator problem. And for this one, it wants to know at what is the height of the object at the instant. So this is going to be talking about your time t when it reaches the maximum upward velocity. So notice it says upward velocity, and we've got the height. So this is our position upwards. So here we're going to need, again, our derivative, h prime at t. And that's going to be 24 plus 36t to the 1/2 minus 32t. And so what we would need to do with this is graph this, since it is a calculator problem. And the max value, when you find that, the max should occur at time t equals 0.316406. And now I need to know the height at that time. So then I would go back and substitute in that t value into h. And when you do that, you should end up with answer choice B. Okay, our next problem is again a calculator problem. And for this one, at number 9, you need to find the acceleration of the particle at time t equals 4. So we have velocity. So since it is a calculator problem, all we need to do is find v prime at 4 in our calculators, and that should give us answer choice C. Okay, number 10. This is not a calculator problem. We need to find the maximum acceleration. So that is going to be over a closed interval. So this is talking about an absolute max. So we already know for the absolute max of the acceleration, we're going to need another derivative here. We have velocity. Velocity is given by this. So for our acceleration, a at t, we have 3t squared minus 6t plus 12. Now we need to go ahead and do another derivative here, because if I'm looking for the absolute max, then I need to test the critical points for the acceleration. So I'm going to look at a prime at t, and that's going to give me 6t minus 6. I'm going to set that equal to 0. And what I'm finding here, just a reminder, I'm finding the critical point for acceleration. That's what we need to be finding here. Right, so here we get t to be 1. So now we're going to come back and we need to look at our different points on A at t. And the place where an absolute maximum could occur would be at either endpoint, so I need to include those, or an absolute or a critical point. So we need to grab all of those. All right, so now we go back and notice we are plugging into our acceleration function. Well, if I plug in 0 up here, then I'm going to get 12. If I plug in 3, I'm going to have 27 minus 18 plus 12. And that looks like that's going to be 21. And I have a feeling that's probably going to be bigger than plugging in a 1 because you're plugging in a 3. But let's go ahead and see 3 minus 6 plus 12. And so that's going to give us 15. So it looks like that our maximum value here of the acceleration is 21. So we have answer choice D. All right, number 11, a particle moves along the x-axis for any time t greater than 0. Its velocity is given by all of this stuff here. The position of the particle is 3 at time 0. What is the position of the particle when the velocity first equals 0? So what we need to do is take our velocity function and we need to graph this and see when is the first time t crosses the x-axis here. So this is definitely, since it's calculator, graph it and find that point. When you are graphing, remember to change t to x. And once you do that, you should get an x value of 0.655136. Once you have that, then we can come back up here and we've got to find our position of the particle. So for that, x at t, notice that we're going to have here at 3, particle's already there at 3, plus, and then I'm going to integrate from 0 to this value here of our velocity function. And that should give us our position when the velocity is first equal to 0. And if you put that in your calculators, you should get answer choice C. Okay, question 12. Again, this is a calculator problem. A particle moves along the x-axis and time greater than 0. Its acceleration is given by blah. If the velocity of the particle is 2 at time 1, then the velocity of the particle at time 2 is. So we're talking about velocity given acceleration. So I know that v at 2, or the velocity at 2, is going to be 2 plus, and then we need to integrate from 1 to 2, because again we're looking from time 1 to time 2, of a at t dt. Okay, and since this is a calculator problem, you just type all that in and hopefully you get answer choice E. Okay, question 13. This is a calculator problem again. And so we're told that the acceleration of the particle moving along the x-axis is given by this. At time t equals 0, the velocity of the particle is -2. For what value of t will the velocity of the particle be at 0? So again, calculator problem here, a couple of steps we can go through. The first thing I would do, and I would probably go ahead and think about here, we do need to integrate this to get back our velocity function. So if we're going to go ahead and I'm going to integrate a at t, and so I'm integrating t plus sine t dt, and we can do that by hand. That's going to be 1/2 t squared minus cosine t dt. Oh, nope, no dt, sorry, brain fart. Okay, and so what I need here now is at time t 0, the velocity of the particle is -2. So we are going to plug in a 0 minus cosine of 0, and then let that be equals, and then plus c. There's what I forgot. Sorry, guys. And so plus c, and all of that should be equal to -2. And so here we're going to have 0 minus 1 plus c equals -2. So c is -1. Right? And now let's put this together. That tells me that the velocity function is now, again, we had this portion here that we integrated. We come up with this. Then we found c is -1. So we can put all of that together and we have 1/2 t squared minus cosine t minus 1. Now I want to know for what time t will the velocity of the particle be 0. This is a calculator problem, so you would graph this and find where it crosses over the x-axis, and hopefully you will get answer choice B. Number 14 is a non-calculator problem. A particle moves along the x-axis. We have its acceleration at any time. If the initial velocity of the particle is 6, at what time t during this interval is the particle farthest to the right? So we know the particle is moving to the right when velocity is positive. We also have told that the initial velocity, so that means at time 0 the particle is at 6, or it has a velocity of 6. So we can set up an integration problem here. We know v at t is the integral of a at t. And so if we integrate this, then we're going to have the integral of 2t minus 7. And so that's going to give us t squared minus 7t plus c. That's going to give us our velocity function. And then we need to go back and plug in our conditions here. We know that when time is 0, that the velocity is 6. So let's go through and plug in here. That's going to give us 6 equals 0 squared minus 7 times 0 plus c. And so our c value is 6. So we know our velocity function is t squared minus 7t plus 6. Now I need to know when this is farthest to the right, which would be super easy if we had a graph, because then we could just see how long or that the function's being below or above the x-axis. So if we graph this, then we definitely need to see where we cross the x-axis. So we have 6 and 1 is for our time. And just a rough sketch here, it doesn't have to be a Picasso. So we have a parabola going on here. We know here 1, and we cross over here at 6. And so farthest to the right over the time interval from 0 to 4. So from 0 over here to 4, so somewhere about a little bit past half, there's your 4. So notice where the farthest to the right would be. Well, the particle is moving right this whole time until it gets to that first intercept of 1. So, and then the particle starts moving back to the left until it gets here, and then it moves back to the right. So the farthest here to the right, I would expect here would be at time 1. So that's going to be answer choice B. Okay, so number 15, this is non-calculator. We have time from 0 to 13. Our object is traveling in an elliptical path. We have parametric equations. And we want to know at the point where t equals 13, the object leaves the path, traveling along a line tangent, at that point. So it wants to know what is the slope of that line. So I need to somehow come up with a dy dx value when time is 13. So we can build that. We have dx dt. Derivative of cosine is negative sine, so we have negative 3 sine t. And then we also have a dy dx, and dy dx, that's going to be for cosine t. And dy over dx, well, we can put this together, and we're going to have 4 cosine t over negative 3 sine t. Well, now we have dy dx, we need to evaluate that at time 13. So that's going to give us 4 cosine 13 over negative 3 sine 13. And I don't see sine or cosine anywhere, but I do see a tangent. And so definitely we're going to get rid of a and b. And tangent, well, what we have here is cotangent, so we would need to flip that over, and we're going to have 4 over negative 3 times tangent of 13. And so that looks like that's going to give us answer choice, looks like D. Okay, so 16 is a non-calculator. And we want to know, we've got equations here and here, that's your position. For what values of t is the particle at rest? Again, we know the particle is at rest when velocity is 0. So to get to velocity from your position, we need to do our derivatives. So we need x prime at t is 3t squared minus 6t. And then y prime at t is going to be 6t squared minus 6t minus 12. And so now we're going to set this equal to 0, and we can take out a GCF of 3t. That's going to be t minus 2. So from this equation, we have times 0 or times 2. Over here, looks like we can take out a GCF of 6 for sure. And so that's going to be t squared minus t minus 2. And again, we have 6 times t minus 2 times t plus 1. And setting each part equal to 0, of course, 6 would go away. T equals 2 or t equals negative 1, but that negative 1 can be thrown out. So we would definitely do that. It's not going to count here. So the place where both of these are going to be 0 at the same time would be at time 2. So that's going to be answer choice C. Number 17, we have a particle moving on the xy plane so that its position at any time t is given by, and so we have our two positions. What is the speed of the particle at time 3? Now our formula for speed is going to be the square root of, and you're going to have your derivative squared plus here the other derivative squared. And that's because it's going to be the rate of change squared and rate of change squared. And really this is just the Pythagorean theorem or distance formula, same thing. A squared plus b squared equals c squared. If you look at a plane, this is your changing axis here, and then here is your changing y's, and then right here, this is their change right there. So that's what's going on here. So we know that this is calculator, but I would go ahead, since these are so simple, we can do those derivatives by hand. So x prime at t is going to be 2 times t. So x prime at 3 is going to be 6. Y prime t is going to be 4 cosine t, 4t. and then y prime at 3, then this is what we can type in our calculators. Go ahead and fill in those formulas there for 6, over here for cosine of 12. And once you do all of that number crunching, you should get answer choice C. And finally, number 18. Here we have a particle. It's moving on a plane. Time is greater than 0. We have our x-coordinate is here. The y-coordinate's here. And that's just another way to say something about position. And so it wants to know what is the acceleration vector of the particle at t equals 1. So we need to go through and do some derivatives. Again, our position is given to us, so that's t cubed minus t. So x prime, the velocity, 3t squared minus 1. And then finally your acceleration, that's going to be 6t. And we need that acceleration at time 1. And so I know the x-coordinate portion of this vector should be 6. So that's going to get rid of all of those answer choices. And so now let's talk about the y position. You're going to need chain rule there. So that's going to be 3 times 2t minus 1 squared times 2. And so that's going to give us 6 times 2t minus 1 squared. And then our acceleration, or our velocity here, we're going to have 12 times 2t minus 1. And then times the derivative of the inside times 2. And already we can see this is probably going to end up being a 24 here if we do our derivative again. So that's going to be answer choice E.